Ladies and gentlemen, welcome. This is going to be a quick little bit about multiple bulb circuits. So we have dealt with our standard circuit. If you take a look right on over here, those two types of circuits, those are our standard circuits where we kind of did the good old Ohm's law where we looked at here's a resistor, there is some current flowing, there's some voltage going through, and we learned the idea of V equals IR. And it was a really helpful piece of information. Now you'll notice Activity 7, Activity 8 introduced two different ways on hooking up these bulbs. So you can kind of look at our targets today. The difference between series and parallel circuit, those are actually our two configurations here. We're going to be able to pull those out really quickly there. And number two, number three is understanding how V and I change in circuits when adding bulbs. You will note that we'll have to use a couple of laws there that we've discovered before in prior activities, and we will get a lot of practice in this tomorrow when we start looking at a worksheet that breaks this idea down. And number three, we're going to talk a little bit about total resistance, and my main part is number four is going to be at the end of this. I'm going to give you a little practice problem to take a look at for class tomorrow. We will go over it first thing. It'll give you a really good idea if you really understood this lesson or not. So, number one, difference between series and parallel. So, difference is this is a series circuit. The way that you know it's a series circuit, it is one bulb following another. So, again, just like a series, like a 7-game series, it's just one game after another and another. You can see just one bulb following. It is only going to be one path. So you will see that the charges can only flow in one direction if you have a series circuit. So it has to hit all the bulbs based upon that one path. Parallel circuit, you will see down here, these are parallel circuits, more than one path. So that is the way that you can tell that you have a parallel circuit. You'll notice that charges can flow this direction, they can go down through that bulb, or they can continue to flow through the other bulb. So you'll see more than one path, and we'll talk about some really nice ways that houses are set up based on series and parallel circuits. So number one, check, done, easy, series and parallel circuits. Now, understanding how V and I change when adding bulbs in a circuit. So let's zoom in on over here. Let's take a closer look at the series cases. So first things first, current. In this activity, you should have saw the compass deflection. Let me get rid of this circle here. Should have saw the compass deflection be about 20 degrees in that first case. When we got into the second case, you should have saw the compass deflection be about 15. Last case, you should have saw about 10. That means the flow going through this wire is equal to what we'll say is about 20. That means the flow going through this wire still has to be 20. That means the flow going through that bulb has to be 20 due to one of the rules that we learned is the idea of flow in equals flow out. Because it is all in one path, we know that whatever's flowing in these wires has to go through each bulb. So that means if 15 is here, how much has to be going through there? 15. How much has to be going through there? 15 as well. Same thing on over here, 10, 10, and then 10, and 10. So that means every bulb, because it is all one path, we have the idea of flow in equals flow out. This is true for a series circuit. We know the current must always be the same flowing through those. Next bit that we have to take a look at. Well, now that we know that these are the same bulbs, we can start to look at the voltages. So using V equals IR, we can actually analyze the voltage of this resistor right here. I just said the current looking at our first circuit, so looking at this bulb, V equals IR, the current was 20. In this circuit, the current is 15. So we see a decrease in current there. Resistance refers to the resistance of the bulb. This is same bulb. So we know that that must not change. So now what we could do is we can analyze if the current goes down, what has to happen to the voltage? The voltage also has to decrease. And of course this starts to make a little bit more sense when we start thinking about a 10-volt battery, let's say. That means that this resistor must have 10 volts across it. So you can kind of look at 10 volts here means 10 volts has to be across this guy. Well, if this is 10 volts, that means this has to be split up equally because they're the same bulb. So we know that this must go 5 and 5. This is of course only due to the case because they have the same resistance. So you can actually analyze that either way. So in this case, if this was 10 volts, we can actually analyze the circuit of each of these bulbs being 2.5 volts. Again, this is only because they are all the same bulb. And we see the 10 volts here. This plus this plus this plus this all must equal 10 volts, and it does. So you start to realize that we can analyze the circuit in terms of voltage and resistance. The last thing that I do want to talk about in this circuit is the idea of the totals. So I want to kind of look at the battery itself. So this battery in this case has to supply one bulb, and then this battery had to have supplied 2 bulbs. I'm sorry, when I say supply, let me X that out. Let's try this again. So what we can do is we can look at 2 of these cases. This is a battery that is 10 volts, and this is a battery that's 10 volts. This is 1 resistor, and this is 2 resistors. We just learned that the flow of charge here was 20, and the flow of charge decreased to 15. And so what we can do is we can actually look at a total resistance. V total actually refers to the total battery voltage. So this is battery voltage. And the battery voltage is equal to the total current times the total resistance. The good old V equals IR, but we're actually looking at it by looking at the entire circuit as one. In this case, the total current is going to be the current through the battery. And then the resistance total is going to be total amount of resistance that the battery has to take. So this is going to be all light bulbs put together. So I want to analyze this. The battery voltage looking from this original circuit, circuit A to circuit B. The circuit A, the voltage stayed the same. Into circuit B, you'll notice that the current went down. It went from 20 to 15. And to keep the voltage the same, we actually have to analyze this and say that the total resistance must go up. So in this case, what we can conclude is adding bulbs in series increases total resistance. The individual bulbs themselves do not change resistance, but these 2 bulbs have a greater RT than this original RT right here. And so that is one of the conclusions that we can make from there. So if I slide on over and take a look, sorry about that, if I slide on over and take a look, you'll notice that we have just kind of did check mark here for a series circuit. Understand how V and I change when adding bulbs in a circuit, and I understand what happens to the total resistance. Now let's take a look at what happens to those 2 things in a parallel circuit. So parallel circuits get a little bit different based on the fact that if you guys saw the currents, you might have saw 15 there. And this actually becomes about 30, and this becomes about 45, and we'll discuss why the current is actually increasing when we add bulbs. It's based upon one factor, and it's understanding that delta V is equal to 0. So I know if I do a complete loop in here, delta V has to equal 0. So if this is 10 volts, this light bulb has to have 10 volts. If I go on over here, if this is 10 volts, this light bulb in this single loop has to be 10 volts. It also means that this light bulb in this outer loop also has to have 10 volts. Notice that I can be an electron. I can make an entire trip around. I can go through here, and if I go through this wire, I need to use all of that energy, that 10 volt or 10 joules per coulomb, before I return to the battery. So that route that you take, that means that that 10 volts has to be used there. So by figuring that out, what I can do is I could start to analyze the different currents in here. So let's make this drawing a little bit neater for us. And I can say, okay, so in this bulb, I can use V equals IR. And I could say, well, the voltage stays the same, the resistance stays the same, so the current has to be the same. So that means I have about I, we can say, going through this resistor. So let's just call that I. Well, looking at this object, we have V equals IR. Voltage is the same, resistance is the same. That means there's another I going through there. So if I have I and I, that means the total amount flowing into this junction right here. Remember, flow in equals flow out. If this is I, because, well, I is the same as I there, if this is I and this is I, that means this has to be 2I, which means each one of these bulbs has to be getting the same amount of current, and the battery has to supply 2I in order to power both of these bulbs. If we go back on over here, take a look at our numbers. 15 to this one bulb, 30 to these two bulbs. So you'll see that actually should link up to your data as well. And we can go on over here. Again, V equals IR. We know that the voltage here, the voltage across this bulb right here, has to be the same as the voltage here is the same as the voltage there. So we can say that V stays the same. They're all the same bulb, so R stays the same. So that means there has to be I going through this bulb, there has to be I going through this bulb, and there has to be I going through this bulb. So what we can do is we can analyze this. If this is I, again, this is I, and this would have to be 2I going into this wire, and if 2I is going into this wire and I is going into this wire, that means at this junction we know that 3I has to be flowing through there. And again, looking back to our original circuit, if that's 15, you'll see that this is 45. Again, we're supplying one more bulb in this situation, which means we need to supply more current. So what we get out of here is by adding bulbs, in parallel, decreases total resistance. And this is easily seen, again, using the V total equals the I total and R total. Voltage of the battery stays the same. So this stays the same. So that means if we increase the total amount of current by adding the bulbs, every bulb needs to get another set of I. That means our total has to decrease when we're going, again, from one circuit to the other to the other. And you can see that by looking at the flow rates there. So this does wrap up one of our second ideas. We understand both of this. How does V and I change in a circuit? In a parallel circuit. And for a practice problem for class tomorrow, here's what we're going to do. We're going to look at a circuit where we have a few different branches. We're going to look at two cases where we have a parallel, and then another parallel branch in here. So you'll see that there are three different ways for charges to flow. And to make matters just a little bit more interesting, we're going to have this be a round bulb, we're going to have this be a long bulb, and we're going to have this be a long bulb and a long bulb. And just remember that the resistances is that a long bulb has a larger resistance than a round bulb. My question to you is going to be which bulbs are brightest, and discuss the voltages and currents for these setups. So talk about a little bit about the brightnesses, which you're going to have to understand the voltages and currents in order to say which bulbs is brightest, why, and on over there. We'll even make it a little bit easier for you. We'll even call that 10 volts. There won't actually be any calculations in terms of currents, but you should be able to break apart a little bit about the voltages and currents in each one of these setups. So I'll be looking forward to that tomorrow in class. You guys have a great night.